Welcome to this session. This session, we are going to do another example on projectiles. So the problem reads, a particle is projected from a point O with speed v meters per second and at an angle of elevation of theta, where tan theta is 4/3. The point O is 42.5 meters above the horizontal plane. The particle strikes the plane at a point A 5 seconds after it is projected. So there are two parts. Show that V is 20. And then part B, find distance between O and A. Now, it's always good manners to start by sketching a diagram to illustrate the information we have in the problem. So let's draw the diagram. So this is the vertical, and then this is the horizontal. So let's assume that this is the point of projection. Let's call it A. And then the particle is projected from a point A, the speed V. So this particle is projected at an angle. So this is how the particle will move. So let this be the speed of projection. And then we have been told that this is at an angle theta. So an angle theta such that tan of that angle is given by 4/3. And from Ochachota, so if tan is given by that, and so if you can draw, so this is V, and then tan is given by opposite of adjacent, so that this will be 4, this is 3. From Pythagoras theorem, this distance should be 5. Not hard to see that 4 squared plus 3 squared square root gives us 5. So we can always now define, if this is the case, this way we have our ux, and this way we have our uy. So the solving, so this point is what is called point A. And this height is 42.5 meters. So from Ochachota, we can also define the cosine of theta, which is given by cosine is adjacent of hypotenuse. So adjacent is 3, hypotenuse is 5. And then sine of that angle is given by sine is opposite of hypotenuse. So opposite is 4, hypotenuse is 5. So A, we say, resolving the velocity of projection horizontally and vertically we have Now for horizontal, we'll have ux by definition. Remember, it's given by u cos theta or cos alpha. For this case, our projection velocity is v. So it will be given by capital V cosine of theta, which is the same as v times our definition of cosine of theta is 3/5. 3/5, which is 3/5 v. Vertical projection. Now, when you throw this thing upward, then it's going down. So that's why I'm showing this direction. We'll have uy is v sine theta, which is the same as v sine theta from this problem is 4/5. So this is 4/5 v. You can call this one equation 1. You can call this one equation 2. This arrow is drawn this one to show that the motion of this particle is downwards. Now, now at this point, if you check this diagram, this is a point of projection. So in this section here, the object is moving upwards. So I want to assume that the motion is positive when we go upwards and then negative when we go downwards. So taking the upward direction, as positive, then so resolving upwards, so we have S. Now remember this distance here, when the object is thrown from this point, so expect now to be going downward. So the distance for 2.5 will be positive. But then now when I'm going upward, then this distance takes a negative, this displacement takes a negative value. So S will be negative for 2.5. And then U, we have calculated U of X, U of Y is given by 4/5 V. And then the acceleration in the vertical direction, because now we are going upwards, so then the acceleration, we're moving upwards, that's against the gravity, that's be negative G. So this is the same as negative 9.8. And then T, we have already been told that the object of the particle strikes the plane at a point A 5 seconds after its projection. So the time is 5. So we know that S is given by UT plus a half AT squared. So which means minus 42.5 is equals to U, this one 4/5 V. Time is 5. And then plus, but it's negative, so we'll have negative a half. And then A is 9.8 times T squared, which is 5 squared. So this will be minus 42.5 equals to 4V minus, so 0.5 times 9.8 times 5 squared, you get 122.5. So collect like terms, so we have 4V equals to 122.5 minus 42.5. So 4V equals to 80. And this implies that V is 80 over 4, which is 20 as required. And then the second part, to find the distance between OA. So this can draw it on the diagram. Distance OA. So remember, this is a right angle triangle. So if we are able, so let me call this one P. If you are able to get PA, then using Pythagoras theorem, OA will be easy to calculate. So let's have this. Let me call this one P. This is O. This is A. And this is 90 degrees. So this is 42.5. Now, so let me call this one X. So distance PA. Now PA is the same as the horizontal distance. So X is given by distance, by speed, this horizontal, times time. And time we have been given as 5. So this is the same as X equals to UX times 5. From our calculation, UX is given by 3 over 5 V. So 3 over 5 V times 5, which is 3V, but V is 20. So this will give us 60. So the value of X, or the value of the distance PA, is 60 meters. Then using Pythagoras theorem, OA is simply the square root of AP squared plus PO squared. So which will be square root of 60 squared plus 42.5 squared. So 73.527, and then 20585 meters. So roughly 73.53 meters. So that is the distance from point O to point A. So that's how we solve that problem.